Hi there, my name is Miss Townsend and I love math. Welcome to Math with Townsend. This video is for grade 10 students who are studying quadratic relations. It's question number 6 on a worksheet about word problems. So let's have a look at the question. It says, a rectangular lot is bounded on one side by a river and on the other three sides by a total of 30 meters of fencing. So there's a diagram here. You can see the river and the other three sides make a rectangle. So what do we know? Well, we know again 30 meters of fencing. The area of the lot in meters depends on the width of the lot in meters, according to this formula. So here's a formula that tells us how to calculate the area of this particular rectangular lot. And as they say, it depends on what the width is, knowing that we have 30 meters of fencing. So before we answer these questions, let's again look carefully at that formula. So again, it's a formula that relates the area of a rectangular lot to the width. And I don't like the way it's written, so the first thing I always do is rearrange it so that it's in proper quadratic standard form. So negative 2w squared plus 30w, and you can tell that there would be a plus 0 here. And that plus 0 tells me that if the width was 0, then the area was 0. And that makes total sense because it's going to be hard to draw. But imagine a width of 0. Effectively, there would be two pieces of fencing touching each other, which means that there'd be no area inside here for the animals to graze or whatever they're doing. So we know that if w equals 0, area equals 0. And again, I see that it's a negative first coefficient. So we have a situation something like this, that as the width increases, the area increases, but at some point it'll reach a maximum and then it'll come back down. If we have something too wide, so if we have, here's the river, if we have too wide of a rectangle, then we don't have very much length. And again, we have a problem with area for our animals. So somewhere in between not wide enough and too wide is this maximum that we'll probably be finding. And in fact, that's what part A says. It says, what is the maximum area? So again, let's rearrange so that it's in proper form. So we know that to find the maximum, we're actually looking for the vertex. So how are we going to find the vertex? Well, we're going to let a equal 0, because by letting a equal 0, it means that we can find the roots, and we can do what we want with the roots. So I'm going to factor. I like factoring when there's only two terms. I find it much faster, but you certainly don't have to. So factoring negative 2w leaves me with w minus 15. So again, that minus 15 number, I know a lot of you have trouble with it. What I did was I took this value, positive 30w, and I divided by my common factor. So positive 30 divided by negative 2 is negative 15. W divided by W means I don't have a W here. And again, think about multiplying. I'd go back to the beginning. So now that I've factored it, now we use our logical. Here's one factor. Here's another factor. If this first factor was 0, I don't care what's in the second factor. If this is 0, I have a true statement. So what value of w makes that first factor 0? Well, if w is 0, this whole thing is 0. 0 times something is always 0. Or if this second factor was 0. So if w minus 15 had a value of 0, it doesn't matter what's over here. 0 times anything is 0. So what value of w makes that second piece into 0? 15. So now we have the roots. And again, if we think about the visualization, this was at 0. Now I know this is at 15. So we were looking for the vertex, though, not the roots. So to find the vertex, we're now going to find the axis of symmetry. And the axis of symmetry is a line exactly halfway in the middle of those two values. So we're going to find the midpoint of our roots, and that's going to give us an axis of symmetry of w equals 7.5. And that also means that the vertex is at 7.5 comma something. We just have to figure out what that is. So we're going to take our original equation. Let's go right back to the top here. 30w minus 2w squared. And we're going to calculate. Now that we know where the maximum occurs, let's figure out what the maximum is. So calculator time, do this math in your calculator. Oops. 30 times 7.5 minus 2 times 7.5 squared. Make sure you know your calculator, please. Make sure you know when it needs you to use brackets and so on. So I get 112.5. So the maximum area of the rectangle is 112.5 meters squared. So again, if you visualize, this was at 7.5, and the maximum here was at 112.5. So did we answer the question? What is the maximum area of the lot? We now know that the maximum area is 112.5 meters squared. So now what? What is the width of the lot when the area is maximized? Okay, so again, we knew we had just discovered that the vertex was right here, or if you want, let's visualize. We had just discovered that we had a root here at 0, a root here at 15. So the mid value, or the axis of symmetry, was at 7.5, and that gave us a vertex of 112.5. So down here we're measuring W, here we're measuring A, so this is W, comma, A. So what is the width when the lot is maximized? Well, it's a width of 7.5 meters, because everything in this equation, in the original equation that we just maximized, was relating width and area. So the value of the vertex is width and area. So the width of 7.5 meters is what maximizes the area. What is the length of the lot when the area is maximized? Well, we were never given an equation involving length, so we're going to have to do a little bit of thinking here. And there's a couple different things you could do. Let's think about this diagram again. We now know that the width is 7.5, and we're looking for the length. So one thing we could do is we could remember that we have 30 meters of fencing as told to us in the question. So if 7.5 meters is here, and another 7.5 meters is here, then whatever's left over must represent the length. So if you do the math on that, you discover that the length is 15 meters. But there's another way you could do it as well, which is to say that we already know the area is 112.5, and we know the width is 7.5. And since area equals length times width, we know that it must be true that area divided by width is length. So we could have done 112.5 divided by 7.5, and that would also give us a length of 15 meters. So logically using the information in the question, or using good old-fashioned math. Okay, so let's see what else we're doing. What are the largest and smallest values of W that can be used in the area formula, and explain? Well, we already sort of know our answer, don't we? Because we've been thinking about this visualization the whole time, we know that we can't have a width smaller than 0, and we also know we can't have a width smaller than 15. And one reason for that is because, just based purely on our understanding of parabolas, that if width is less than 0 or width is greater than 15, the area is negative. And that doesn't make any sense. And because it doesn't make any sense, certainly it can't be true. Another reason is, let's think about it visually. And let me draw my really bad sketch here again. Here's the river, and here's width and length. If we somehow were to make the width 0, so I'm going to draw a tiny little bit, but I want you to pretend that I'm not drawing here. So if we make the width 0, here's the length, and here's the length. I know that it's impossible to get below 0 for the width because you can't have a negative width. But what if we made the width 15? River, 15. 15. Well, haven't I used all of my fencing? Which means that there's no more room here. to have an actual fence. So in fact, this would look like 15, 15, no length at all, which means it's really just two fences touching each other with no room for animals. But I think the clearest way of understanding that is understanding this particular diagram, 0 and 15. Even though they don't make a really good looking fenced area, you certainly can't. You can sub 0 into the equation and get a mathematically viable answer. You can't sub anything below 0, and you can't sub anything below 15. So I hope that made sense as a bit of a thinking question. And that's the end of question number 6.